So we studied density, and now we want to do an example to understand how we come up with a density in a given experiment. So a woman wants to test if a ring is made out of platinum by finding its density. She finds the mass to be 5.84 grams, and she finds the ring displaces 0.556 cubic centimeters of water. Is the ring made out of platinum? And we are given the actual density of platinum that we must compare it to. So we learned that density is a measure of a given mass per unit volume for a certain substance. So here we have that the mass is 5.84 grams, and we have the volume of 0.556 cubic centimeters. And it says here that the ring displaces 0.556 centimeters of water. That's analogous to you sitting in a bathtub. The amount of water that you displace is the volume of your body. And same thing with the ring. The amount of water that it displaces is its given volume, how much space it's actually taken up. So now that we have our mass, we also have our volume. We have one unknown factor, which is our density. So let's go ahead and plug in our values. And when we carry this calculation in our calculator, we end up with 10.5 grams per cubic centimeters. That's our density. Now, is the ring made up of platinum? No, because I gave you the density of platinum to be 21.4 grams per cubic centimeter, and this is not made up of platinum. Okay, now go ahead and try doing a density problem yourself, and replay the video to see if you got the correct answer. What is the density of a metal if 100.0 grams sample causes the water level to rise from 25.0 mils to 37.8 mils? So our mass in this case is 100.0 grams. We always want to start with what we're given. And our volume is what? Well, it tells us the water level rises from 25.0 mils to 37.8 mils. And remember, the difference in that water level gives us our volume. So we would do 37.8 minus 25.0, and we end up with 12.8 mils. Okay, so that is our volume. Now we're ready to plug it into our density equation. Density is equal mass over volume. So our mass is 100.0 grams, and our volume is 12.8 mils. And when we go ahead and we plug this into the calculator, we end up with 7.8125 grams per mil. But we are limited by 3 significant figures here, and so we end up rounding our answer to 7.81 grams per mil, and so that is our density. Don't forget your number and don't forget your unit. Grams per mil is the same as grams per cubic centimeter, and it's one of the units of volume. So let us see how we can use density as a conversion factor between volume and mass. So if the gasoline in an automobile has a mass of 60 kilograms and a density of 0.752 grams per cubic centimeter, what is the volume? Well, we know that we have our mass is 60.0 kilograms. And our density in this case is 0.752 grams per cubic centimeter. We always want to write our givens and our unknown. Remember that when we say the density of something, we're equating its mass per unit volume. So we can use that as a conversion factor. When we have the mass and we have the density, we can figure out the volume from there. So for example, when we say that the density of water is 1 gram per mil, we're saying that for every 1 gram of water that we have, we would also have 1 mil of water. So we're equating mass here to volume. So in this case, when we say that the density of our gasoline is 0.752 grams per cubic centimeter, we're saying that for every 0.752 grams, we will have 1 cubic centimeter as well. So this is the mass and this is the volume. So let's see how we can use that. We can start with our given, which is 60.0 kilograms, and we want to use our density as the conversion factor. However, our density is given in grams per cubic centimeter, and our mass is given in kilograms. So we can't do that just yet. We have to convert our kilograms into grams. And kilograms is the bigger unit, so it gets the 1, and the conversion factor is 1,000, or 10 to the third. Now we can go ahead and use density as the conversion factor. And since grams is on the top, grams is going to go on the bottom, and cubic centimeters is going to go on the top. So we know that for every 1 cubic centimeter, there is 0.752 grams. And you see how the kilograms cancel, the grams cancel, and we're left with cubic centimeters, which is our volume here. So when we go ahead and we plug this in, we end up with 7.978 times 10 to the 4th cubic centimeters. Or, since we need only 3 significant figures, we will rewrite it like so. And that becomes our final answer. And you see how we used density when we were given the mass. We used density as a conversion factor from mass to volume. So go ahead and try using density as a conversion factor in the following problem, and then replay the video to see if you got the correct answer. A drop of acetone has a mass of 35 milligrams and a density of 0.788 grams per cubic centimeter. What is the volume in cubic centimeters? Well, we always have to write our givens, so we know what we are solving for. So our mass is 35 milligrams. Our density is 0.788 grams per cubic centimeter, and we want to know our volume in cubic centimeters. Okay, so we're going to use this as our density as a conversion factor, because it's saying that for the fact that it has a density of 0.788 grams per meter, is saying that for every 0.778 grams, there is 1 cubic centimeter. So this is mass to volume conversion. So we start with our given, which is mass, and it's in milligrams. We can't go ahead and use our conversion factor yet because it's in grams per cubic centimeter, and we have milligrams. Make sure your units match up, or else you will get the wrong answer. So we have to convert our milligrams into grams, and we know that grams are bigger, so it gets the 1, and by a factor of 1,000, or 10 to the third. So now we have grams. Now we can use our conversion factor. Since grams is on the top, grams is going to go on the bottom, and cubic centimeters is going to go on the top. And now we're going to use this conversion factor. For every 1 cubic centimeter, there is 0.778 grams, right? So you see the units cancel out, and we're left with our desired unit of cubic centimeters. Okay? And when we go ahead and we carry this out, we end up with 4.4 times 10 to the negative 2 cubic centimeters. Okay.